You want to go first, or are you still
My
mapping?
robot's already navigating. We got connection here. Yeah. So this is the presentation I do every month. I came in and I made a map, and I saved the map, and now I'm navigating on the map. I'm going to clear that stuff off with a clear cost map. Let's see here. Oh, this always breaks. Oh, let's see here. I'm up on the screen here. So there's that. Bear with me.
What are your cursors?
Here we go. Clear cost map. So again, this is a Raspberry Pi 3 inside of the BotVac. And I've actually installed Ubuntu Mate. And what you have to do with that is, I find you have to use really a monitor to get the IP address, and then you have to actually install the SSH client and server, and then you can go headless. Then you can install the Raspberry Pi version of ROS. Be sure and install the Raspberry Pi version, not the Intel version, because that won't work. Tried that. Bear with me. Here goes. Oh, another useful thing is Minicom. How many of you know Minicom? It's a useful thing to load in so you can see the status of the USB port. In fact, with the Nito API, you can type help and it spills all the API commands and stuff, so you can check the charge level and stuff like that. So that's pretty handy. Oh, bear with me here. I'm going to clear this local cost map. It's the last thing I do. Tick-tock, tick-tock. Oh, here it comes. ROS service call, move base, clear local cost map. I shall navigate to the other side of the room here. Bear with me. Let me get a screen up here. Tick-tock, tick-tock, boom. Okay, looking at the map. Is the map on the screen? Yes, more or less. Okay. So this should clear this local cost map here. I don't know where that residual is coming from. Sure is slow. Let's press enter and then execute the command. It works much better that way. One thing I also do when I start these things off, I use the smartphone as my hotspot, because as you go from place to place, it's impossible to set up ROS, for all the IP stuff. Oh, you see that cleared? Okay, that cleared, and so I usually set up with a ping, and that way I can monitor the latency. If it gets too far out of spec, that's what I notice. So I'm going to go back to my map, if I can get there. Tell you what, I'm going to bring back the local screen then. It's probably off the screen here somewhere. Anyways, if I could bring my map back up, I could click somewhere else and the robot would autonomously navigate there. So I guess what I'm proud of this week, this month, is really getting it down to just this battery, smartphone battery, Raspberry Pi 3. Again, and it's got a 16 gigabyte micro SD card. I'm using Ubuntu Mate and putting the ROS for Raspberry Pi on it, and then installing the intro to ROS package. Thank you very much, Ralph Knock. Ladies and gentlemen, big round of applause. This is really the best way to learn ROS, because you can learn ROS this way, and then when you're finished, you can just replace it with a regular dirt bin, and it'll vacuum your floors. I'm done.
So you heard a comment about we give stuff away occasionally. Somebody brings in some odds and ends. So one of those, it turned out I had got some little odds and ends, and one of them turned out to be a 3-axis gyroscope. It's a Parallax. Familiar with Parallax? They're up in, where is it, Roseville? And they also make a thing called a propeller. I just happened to have a propeller card. So I thought, gee, that's interesting. That'd be a neat little project. What happens if we take the gyro, hook it into the propeller card, and get some software to fire it up? And that turned out that was not a whole lot of fun. It worked, and I got the data on the screen. And now what? So I thought, well, it'd be kind of interesting to try to see if I could make some servos work. So I went out and got the drivers for the servos, brought those in, had the servos sitting on my desk, and got that working, and I thought, well, now what? I thought, it'd be interesting to make a prototype airplane.
Whoa.
So it turns out, has anybody tried to find a hobby shop lately? They're really scarce items. So anyway, I found Sheldon's finally up by the airport and ended up with some RC parts. These are control horns. They hook into the servos through some steel wire. And I ended up using an RC battery. It's a 9.6 battery, and I have a voltage regulator here to drop it down to 5.1 volts. It turns out the Parallax card will run off of a USB plug, so when you're programming it, you can be running off a USB power. But it turns out one of the pins, you can run 5 volts into it, into the pin, and then run the card itself off of a battery. Now, what I came up with here is probably the simplest thing you could possibly do with a 3-axis gyroscope. By the way, for those of you not familiar with this, the gyroscope itself is about 3/8 of an inch on the side. It's 3 axis. If the other side had had that during the war, we would have lost, right? Big war. In any case, it's just amazing what can be done with this. But what I did is take the information and did the simplest thing I could, simply take the output and put that into a format that the servos would understand. And so all I'm doing is taking the gyro and making the servos work counter to the direction I move the airplane. Yaw and pitch and roll. So if you actually did this for real, this would be a disaster. But the next step is to add what? Add an accelerometer, 3-axis accelerometer. And then you probably need to have a magnetic compass. Well, for $29, Parallax, I believe it's $29, Parallax has an IMU, it's called, and you can get all 3. So I kind of think this is too tempting. It doesn't take much to put an IMU in this thing, and then that's all I have to do is then just program, right? From this, I should be able to do things like develop PID capability to make the thing smooth out the funny conditions, and then Kalman filters to be next. So this whole thing can lead to about a year's worth of fun. Okay, now
use our new pilot.
Let's yeah. This is the first time I ever brought a robot that didn't have wheels. Is that allowed in this club? You can bring robots that don't have wheels.
You gotta show it.
As long as you aren't flying.
Needs another
Well, you know,
We're fairly sure we're safe on that.
the thing I'm tempted to do with this is by just replacing this part back here. You've seen those big foam sailplanes?
Yeah.
I have a feeling you probably, by doing this little lightning of things here, I could probably actually control something for flying. In any case, now, this, sometimes things don't travel well, so let's see what happens here. You have to be careful when you turn this thing on because it instantly tries to sense that you're doing something. So I'm going to set this down. And try to balance a little bit here. Sometimes it has, because of an erratic start.
Nice.
Okay, now I'm going to reset it. Okay, there's a button on the Parallax card that you can reset. Okay, now we're back. Okay, now it's a little hard to see this, but you notice if I move it, that's the ailerons. I'm in roll, and the ailerons are running counter to what I'm doing here. Now, if I do yaw, you notice that it tries to compensate. The rudder is compensating for yaw, push the other direction. Okay, and then if I do raise the nose up and down, you can see that the elevator. Okay, now what's funny about this thing? Oh, by the way, I have a liquid crystal display here that I can actually see the readings. It's a serial liquid crystal display. And I can see the X and Y and Z axis and see what the readings are coming in. So watch this. This is kind of funny.
Okay, now let's see, let's try resetting it. The algorithm I'm using is just incredibly simple. But I'm not sure if that's only because I'm getting like the in bit is changing and the gyro or something causing it to do that funny operation. Anyway, it's been a fun project.
That's awesome.
That's what I use.
So, George, on the display, you were showing what the computer was thinking, correct? I saw some stuff dancing around on the display.
Well, yeah, all it's doing is taking the raw servo, let's see, it's taking the raw gyro readings, and I'm displaying X and Y and Z, so I can see those. So, you know, what happens if you try to do this, something like this for real, you get into all kinds of weirdness. It'll do things like decide, oh, I want to oscillate, right? And
That's why you need your IND.
yeah, right. That's the reason why you need a lot more complicated things. Okay, thank you.